Hi everyone, this is the Quadratics Unit 4 test review for Algebra 2. This test includes everything from the three different forms we covered, so standard form, factored form, and vertex form. It involves graphing and being able to identify the different key features. It involves the focus and directrix material, the regression, and there's a little bit of transformations in here. But the main focus of it is on writing and graphing quadratics. So there are, on your test, I believe there are the same amount of questions. So there's going to be about 15 questions on your test. There is a little bit of multiple choice, but the majority of it is free response. But all of the material that's on your review is going to be covered on your test. So if you can do the review, then you're good to go. So for number one, you've been given the different forms, and we want you to write an equation from that form. So in this case, you're not given any information, so you can make A, B, and C, you can make R1 and R2, you can make H and K, whatever numbers that you want. It's just, on your test, we're going to give you the three different forms, and you'll have to be able to identify which is which. So we're giving you the practice of trying to write a form to being able to identify it. So I'm just going to pick some random numbers for A, B, and C here. So let's say that my A value is 3, my B value is -4, and my C value is 2. So if I were to write that in standard form, I would have 3x squared minus 4x plus 2. And that's all that you have to do. For a factored form, I'm going to keep the same A value of 3. I'm going to make R1 equal to 2. And let's say R2 is equal to 1. You are going to go through and replace those values in your equation. So you're going to replace A, R1, and R2. Notice that there is that subtraction symbol, so you have x minus r1. So whatever you put as your r1 and r2 are going to flip sign when they go into the equation. So you're going to have a value of 3. Your formula, x minus r1 is 2. Actually, I'm going to make r2 -1 just to show you the sign flipping. If r2 is -1, then you have x minus -1. So when you simplify, you have 3 times x minus 2. And then here, this is going to turn into a plus sign. So you're going to have x plus 1. So that would be a factored form where you have two sets of parentheses side by side. Vertex form, let's keep our A as 3. I'm going to put my vertex, so remember your vertex is at HK. Let's say that is at, I don't know, 4, -1, okay? So I'm going to go through and I'm going to replace A, H, and K with those letters. So my A value is 3. Remember that your H value always flips sign. So your H value is 4. You're going to have x minus 4 squared and then -1 in the back of that. So you just have to be able to identify what the three different forms look like. Okay, for number 2, you want to write a quadratic equation, I should say of a curve, and you are given the location of the vertex and 1 point. What equation form should you use? So the key thing here is that you were given the vertex and you were given 1 point. So pretty much anytime you see the word vertex, you should automatically think vertex form. So using vertex form, and vertex form looks like this. Okay, so that's it. All right. Number 3, we want to write a quadratic equation of a curve, and we're given the location of 2 x-intercepts. So remember that x-intercepts are the same thing as roots and the same thing as zeros. So you want your equation to include that, so we're going to use intercept form. And that looks like this. Okay, and that's it. For number 3, I would definitely use your calculator for this one. The decimals in here are kind of funky. I think on your test they might be whole numbers, I don't remember, but use your calculator for it. So I would type the standard form, so this equation, I would type that into your calculator in the graphing page, and your number that's in the back here, so this last number, that is the y-intercept. So your y-intercept is going to be at 0, -9. You cannot tell the vertex by looking at this in standard form. So I'm just going to quickly kind of sketch a picture of what you're going to see on your graph when you do graph this in your calculator. It's going to go off of the graph. So I'm just going to label it. When you graph it in your calculator, your vertex is going to be at -2.5, -27.8, okay, that's just like a super rough sketch of what your graph is going to look like. So when it says vertex, remember that you can go to graph trace and then keep going. Since this point is at the bottom of the graph, your calculator is going to say the word minimum when you hit the point. So my vertex is -2.5, -27.8. Your axis of symmetry is always x equals whatever the x value of the vertex is. So you're pulling that number and you're putting it there. So we've got x equals -2.5. Is it a maximum or is it a minimum? Well, we know it's a minimum because it's at the bottom of the graph. The domain for all of your parabolas is the same thing as it was last unit, so it's -infinity to +infinity. Your range, also similar to last unit, since this is a minimum, the bottom of the graph, so remember minimum is, range is all the y values. So your lowest y value is here, and that happens at -27.8. I'm going to put a square bracket because I actually touched that point. And then I'm going to have all the y values above that point. So I'm going to go infinity, but we can't touch infinity, so it always gets a parenthesis. So that would be my range. That page. If you look back at the equation, this number in the front, that is your a value. So you don't have to solve for that or anything on this. The next question wants you to use that information to write the equation in vertex form. So just quick refresher, this is what vertex form looks like. And your HK is your vertex, and that was at -2.5, -27.8. So we are going to be substituting A, H, and K. Well, I shouldn't use green, sorry. Your A value, if you look back, I'll go back. So our A value is 3. Sorry, my dog just yawned. You are going to just replace what you've got. So if my H value is -2.5 in the equation, you're going to see +2.5. And that would be your equation in vertex form. Remember to put the exponent of a 2, so that right there. A lot of you on your quiz didn't do that or forgot to do it, and you got points taken off, so make sure you're watching that when you're taking your test. Next is the focus and vertex and directrix. So you're going to plot what you're given first. So I have my focus at 4, 3, and my directrix at y equals 9. So I'm going to go to my graph, my focus is here, and my directrix is at y equals 9, so up here. Okay, I'm looking for the missing key feature, which is the vertex. your vertex is always in the middle of the focus and the directrix. So the focus and the directrix are 1, 2, 3, 4, 5, 6 units away. So in the middle of 6 is 3. So I'm going to go 3, and that is going to be my vertex. So when it says plot and label the vertex, this point is at 4, 6. Okay. I'm going to sketch the parabola. Oops. I'm going to sketch the parabola. So remember that in order to do that, you need to have a p-value. Since I am 3 units in between the vertex and the directrix, or the vertex and the focus, the p-value is 3. Since the focus is below the vertex, that means that my graph is going to be opening downwards, which gives me a negative p-value. To figure out how I actually get the other point on the graph, you're going to do 2 times p, and you get -6. So I really don't want you to pay attention to the negative sign. It really only matters in the context of writing your equation and when you're looking at the p-value. But when you are just graphing, it doesn't mean that you only go 6 units left. You're going to still go 6 units in both directions. So if you think back to like absolute value, it's kind of a similar concept of you're still 6 units away from the focus. So I'm going to go 6 units for my focus to the right, put a point here, and then the same thing on the left. And then you're always going to start out at the vertex and then connect the dots to those other points. Okay, so that is what your graph should look like. So writing the equation in vertex form, I will probably print out a cheat sheet on the day of the test and give you that equation like I did for the quiz. You're just going to go through and fill in those numbers. So we said that our p-value above was -3. Remember, your vertex is at h, k. So your h value is 4 and your k value is 6. And then you're going to go through your equation. We're going to substitute p, h, and k. H is going to change sign. So the only thing that you can simplify here is the very bottom of that fraction. So we're going to have 1 over -12 x minus 4 squared plus 6. The most common mistakes that I saw on the quiz were that if it pointed down, you forgot to write the negative sign. So if it's going down like a frown, think like someone's frowning, they're sad, they're in like a negative mood, it needs a negative sign in front of your equation. And I also saw people forgetting to put that squared symbol. Some of you forgot to change the sign of h when you put it into the equation, so just be sure you're watching those little detail parts. Okay. Number 8, writing it in vertex form. I would graph this. So I'm going to say graph. And then once you graph it in the calculator, you can use graph trace to find your vertex. So on this one, I graphed it on my calculator and did graph trace. And my vertex was at -115. And then remember, your a value is that number there. So I'm going to rewrite the equation. And then I'm going to go through and replace a, h, and k. So a is 5, h is -1, so when it goes into the equation, it's going to turn positive. And then k is 15. K does not change sign, h is the only thing that changes sign. So that is that equation in vertex form. The next one involves a little bit of solving. I think we maybe only did one of these in class, where you have to solve for A when you're given the vertex and another point. So what you're going to do for this one is you're going to substitute what you know into the equation. So the vertex is still HK, and the other point is X and Y. So that means your H value is 2, your K value is 5, your X value is 3, and your Y value is 7. You're going to go through, you're going to replace all of those things in that vertex form that I gave you, and then you're going to solve for A to write your equation. So Y is 7, so I'm going to put a 7. I don't know what A is, so I'm just going to leave it as A. X is 3. H is 2, so I have -2. And then K is 5. Then I'm going to simplify. So 3 minus 2 is 1. 1 squared is just 1, and 1 times A is just A. So I have this. And then solve for A by subtracting 5 from both sides. So your A value is 3. And then once you've got that, you can write your equation. So when you're writing the vertex form, X and Y should still be there. The only reason that you replaced them in the process that I just went through was to solve for A. But once you have A, you can kind of disregard X and Y, and they just go back to being the letters X and Y when you write them into the equation. Okay, number 10 is transformations. The transformations from absolute value are the same as the transformations for quadratics. We're just trying to spiral that information back in so you don't forget it, but they work the same way. So here we've got a negative sign in the front. That's going to make your graph going from facing up like a smiley face to going down like a frown. So this is flips over the x-axis. The 2 that's in the front here, this is your A value. If your A value is larger than 1, so it's either a whole number or it's a fraction where the top number is bigger than the bottom number, the majority of time it'll just be a whole number bigger than 1. That means that you have a vertical stretch. If the number in front was like a 1/2, for example, then that would be a vertical compression or a vertical shrink. The negative sign that's in the front has nothing to do with vertical stretching or vertical shrinking. So it is, if you see a negative number in the front, don't think, oh, that's smaller than 1, so that's a vertical compression. The negative sign has nothing to do with the vertical stretching or shrinking. You're just looking at the number in front of parentheses, okay? The +4 that's in parentheses, remember X lies, so you're going in the opposite direction of what you think. So this is actually going to go left 4. And then the -3 that's in the back, that's going to take you down 3. So a movement left or right happens inside of the parentheses, and a movement up or down happens in the very end of the function. Okay, going on to regression. This is pretty much all calculator. So if you literally have no idea how to do anything else on this test, you can still get quite a few points by just being able to plug things into a calculator. So please, the next couple of days that we have for review, make sure if you don't know how to use the calculator, you ask me. So when it comes test time, you're good to go. And these are easy questions for you, easy points. So 11, you are given 3 points, and it wants you to find the equation of the parabola in standard form. So you are going to make a table from these values. So I've got 3, 2, 2, 5, and 1, 4. So on your calculator, this tells you that it's a quadratic function. So you're going to do a quadratic regression, not a linear regression. So you're going to enter these into list and spreadsheets. You're going to go to menu after you've put it in list and spreadsheets. 4, 1, 6. Okay? So when you do that on your calculator, you're going to get an A, B, and C value. And using this general form, you're going to substitute that A, B, and C value. So when I did this in my calculator, A was -2, B was 7, and C was -1. So that would be your equation. Question 12 already gives you your data in a table form. You just have to type it into your calculator. So your calculator is not going to recognize the letter T and the letter P. This is crooked. So you're going to need to enter it as X and Y. So you're going to make the top part of the table, the top row is going to be X, and the bottom row is going to be Y. So you're going to go through, enter that. You're going to run a quadratic regression, so menu 4, 1, 6. And then you're going to do the same exact thing that we did on the other question. So your A value is -0.213. I'm going to round all of these numbers to 3 decimal places. If you're not comfortable with rounding, like you're still struggling with that topic, you can just write down all the numbers that your calculator shows you, and that's fine. Okay, so that is the standard form quadratic equation for that data. Okay, oh, excuse me. Number 13, it says use the model to find the population in 2007. So looking back at your question, the number of years that it's talking about is not talking about year 0, as in like life never existed or whatever. It's talking about year 0, meaning that it is the year 1996. You're looking at the number of years between 1996 and the number that it gives you. So at year 0, that's 1996. Year 1 is 1997, and so on. So when it asks the finding the population in 2007, it is not the year 2007. It is the number of years away that 2007 is from 1996. So to figure that out, you're going to do 2007 minus 1996 is 11. So 2007 is 11 years after 1996. So the value that you're using is 11, not 2007. So your X value is the number of years. On the table, it's called T, and that number is 11. And the Y value is the number of people that are included in that population in 2007. So in your calculator, you have 2 options. You can either graph the equation. So you can either graph this equation here and then hit Control T. So I'll write that out. So option 1 is to graph your equation and then Control T and then find the X value of 11. The Y value that goes with that number is 20.113. Your second option is that you can type your equation, so the one that's highlighted here, into the calculator and replace the x's with the number 11, the table way or the replacing way is going to get you the same thing. So it doesn't matter which way you do it. Either way, you're going to get 20.113. So that is in thousands. So that is 20.113 thousand people. It's not 20.113 people, it's 1,000 people. Okay. All right, for our last page, number 14 gives you like a scatter plot, and it wants you to determine which one is linear and which one's quadratic. A quadratic has a curve shape and linear is a line. So your goal is to try to draw either a curve or a line that goes through as many points on the graph as possible. So if I'm doing the first one, my shape is going to look something like that. That's more of a curve shape. So this one represents a quadratic relationship. On the second one, that's going to be more of a line shape. So this is a linear relationship. Okay. Number 15 is straight from the notes that we did the other day. You have someone playing volleyball and they hit the ball from a ground level. The height of the object represents h in meters and t represents time in seconds. And then you're given the equation that models the player hitting the ball. So I would take that equation and step 1, I would graph the equation that you were given and see what it looks like. It wants to know how many seconds is the volleyball at or above 32 feet. So step 2 is going to be hit Control T and pull up a table. H of t, so your equation says h of t equals blah, blah, blah. That's the same thing as the letter y. And in this case, that's representing height. Okay, letter T is the same thing as x, and that's representing time. So if it's asking you how many seconds is the volleyball at or above 32 feet, feet is a measurement of height, so it's talking about a y value, not an x value. So it's telling you that the y value you're looking for is 32. The previous example, your x value is being replaced, now your y value is being replaced. So don't get the two confused. Make sure you're paying attention to what letter is representing what units or what variable. So you're going to, on your table on your calculator, you're going to look for where the y value is 32 or larger, because it says how many seconds is the volleyball at or above 32 feet. So that means I can be at 32 feet or I can be larger than that number. So when you pull up your table, you're going to see these values. Okay, so those are the values where you're at 32 or higher. You may also see negative x values. Remember that x stands for time and you can't have negative time. So those values can just be kind of trashed. So the time amount that I'm looking at is from 0 to 2. So my height is at 32 feet or above between 0 and 2 seconds. And I'm including those points because I'm either at 32 or I'm higher than that number. So if I were to write that in interval notation, you would have 0, 2. So you are including those times. Okay, cool. So I think that we have covered everything in this review that we need to for your test. I will be giving you a cheat sheet, and on there it will have the parent equation for when you're doing the focus, directrix, and vertex problems. And I think other than that, I don't really think that we're going to give you anything. So make sure that you look over the standard form, vertex form, and factored form, and you know what those look like, and memorize the formulas that go with it. So that way on your test, you know how to use those and what you're replacing. Anything else? Yeah, I think that's it. So if you have any questions, please let me know in class prior. You can come see me for tutoring. Let's get this out of the way so you can go into Thanksgiving break not having to worry about anything math related. Okay, so happy studies, and let me know if you have any questions. Y'all have a great night.